Hello and welcome to yet another round of Quest, the weekly inter-school science quiz brought to you by the National Council of Science Museums and Doordarshan Kendra, Kolkata. We have with us the director of Nehru Science Centre, Mumbai, Mr. G.S. Rautela. Let's give him a very warm welcome.
Hello.
Ready to ask us very interesting questions again, Mr. Rautela?
I'll try my best.
Well, are you enjoying Calcutta? Are you enjoying your stay here?
Well, it's quite warm, but the rasgullas anyway pretty.
Rasgullas were pretty. Well, let's hope the warmth transcends into the hot action that we see today in our quiz. We have two of the premier schools of Calcutta sitting here. On my right is the J.C. Bose team. They are the boys from St. James High School. And you are?
Hi, I'm Shantanu. I'm studying in class 12.
Hi, I'm Vaibhav Singh. I'm studying in class 12.
Hi, I'm Atul Srivastav. I represent St. James School.
And are you also in class 12?
Yeah.
Just got promoted?
Yeah.
Just got promoted. And on my left, we have the C.V. Raman team. They are the boys from La Martiniere for boys. And you are?
Hello, I'm Harshaditya Poddar. I'm studying in class 12.
Hello, I'm Milan Banerjee. I've just been promoted to class 12.
Hi, I'm 𝐃𝐞𝐦𝐨𝐬𝐭𝐫𝐚 and I'm in class 12.
Any of you want to become scientists in later life?
Yeah,
Hope
I want
so.
to become a genetic engineer.
A genetic engineer, no kidding. And how about you?
Astronomer.
Gaurav, you want to become an astronomer? I like all Gauravs, you know. There must be some reason for that. All right, let me explain the rules. They are fairly simple, the same as every week. We've got 7 questions in all. The first 4 are direct. Each team will get 2 direct questions. You have approximately 15 seconds to answer, at the end of which we will pass to the other team if you have not attempted to answer. 20 points for the right answer, 10 on passes. If neither team answers, we go into the audience. The last 3 questions will be on the buzzer. Remember, teams, in the buzzer round, when you hit that buzzer, you must be ready with an answer. 20 points if you get the right answer, minus 10 if you get it wrong. And if you get it wrong, we'll go into the audience. So let's not waste any further time and get on to the very first question, which is for the J.C. Bose team. And now the very first question, which is for the J.C. Bose team, seated on our right.
Your question is, this particular cardboard has been divided in 2 parts, half is white, half is black. And I have 2 gray letter V on it. On the right, the gray looks darker, on the left, it is lighter. Do you see that? Yeah. You see that? This gray is darker than lighter than this one. Okay. The question is, I'll cover this up with a white paper. I have 2 windows now. Do you see the gray inside the window same? Okay. Now the question is, why does the gray, which seems to be similar, look different on a black background and the gray background?
Black formed when it is absorbed. When electrovision less light is reflected from the surroundings. Yes,
Yeah.
now, we observe color black when all the light falling on it is absorbed.
Yeah.
So now, when the gray portion on the black piece of the cardboard, black half of the cardboard, there, since all the light is absorbed by the surroundings, therefore the light reflected from the gray strip, the gray V, is less as compared to when it is reflected from the white half of the V, white half of the cardboard.
So that should have given it a little darker color, but it is lighter on the black background. If less light is coming, it should look darker. That's not the correct answer. Could you try?
On the case of the black one, the light falling on it is all absorbed, and therefore the surrounding of the gray, the light reflected by the gray, the surrounding is not as bright as that in the case of white one, and therefore the light reflected from the gray in that black portion is has a greater intensity, means it produces much more, I don't know the word.
Well,
It
I
is
think
actually-
you're not quite very close. You aren't very close to the answer.
It
Would
is-
audience like to try?
Any takers in the audience? None? I guess, Mr. Rautela, you'll have to do the honors.
Well, I'll try to explain to this. Well, this is a question of contrast, as I think you all understand. In a black background, the contrast is better than in a white background. Now, another very important question here is our cones in the eye. You know, there are cells and cones in our eye, which are rods and cones. And the cones, if they get sensitized, some of the cones to black color, and in the gray also has some black. You know, when we prepare gray color, it has a black color. So that gets less sensitized to that gray, which is in this particular one. The remaining cones get less sensitized to black, so you look it as lighter. Whereas that doesn't happen on the right side. There's another example I could show you this. I have two red strips, one on black background, one on white background. They look quite different. Okay? So one is the contrast, the second is the cones which get sensitized to one particular color in one background doesn't respond to if that color is available in the strip which we are watching here. If black is available here, red has a little bit of black already. So that's why you feel it is lighter than the red which is on the white. So you don't get any point for that?
Well then, no score to either team, and we move on to the very next question, which is for the C.V. Raman team. No score to either team so far. The next question of today's episode of Quest is for the C.V. Raman team.
Well, your question is, I have one plastic piece here. You could see the shape of this. When I rotate this anti-clockwise, it rotates and loses energy and stops. Whereas if I rotate it clockwise direction, it stops and comes back. Your question is, why does while rotating it on the clockwise direction, it comes back? Once again for you. And again on anti-clockwise, it doesn't go clockwise. So only while rotating in the clockwise direction, it comes back.
One side of the yellow bar is heavier than the other. So when we rotate it clockwise, it provides a negative torque which causes it to turn backwards, so that the center of gravity reaches stability, it reaches its lowest position. So as a result, it turns backwards as well.
Why not in anti-clockwise?
That side is lighter. Its center of gravity is not shifted towards that side because this side is heavier.
Well, why does it happen so?
It is due to the positioning of the center of gravity, due to the mass of the way in which the mass has been distributed in that rod.
It is the tendency of the center of gravity to reach its lowest position, its most stable position.
Equilibrium position.
Yes, I think I would give them 20 points. They're very close to the answer. But I would like to add something to this. I think for getting 20 points, let's give them a big hand. Well, this particular piece has been crafted in such a way that there are two ellipsoids. It's an ellipsoid, and it is not symmetrical. Two ellipsoids and two axes not symmetrical. As a result, the distribution of mass is not uniform, as they said. So when you are rotating in an anti-clockwise direction, it doesn't have a backward torque to bring it back when it stops. Whereas in other direction, when it is rotated in clockwise, because of an unequal distribution of mass, it tries to recoil back from the stationary position as soon as it stops. All right?
20 points then to the C.V. Raman team. That's the boys from La Martiniere School. J.C. Bose team, time to get your scores moving in a clockwise direction too. Well, we'll be back very shortly with the next question, which is for the J.C. Bose team. With the scores reading 20 points to the C.V. Raman team, J.C. Bose team yet to get off the score. They're going to face their next question. Mr. Rotella, what do you have for us now?
Well, I have two sticks, not to beat them, but do an experiment.
Well, we don't have too many naughty students here.
Yeah, I need a volunteer for this.
Any volunteers, please? We do have? Yes, why don't you come up? Come and stand here.
To stand here. Now the experiment is, I have two identical sticks of the same metal, same diameter. What I have done is I have fixed some load at the one end of this pipe. Now I drop this both together, these pipes together. Your question is, will they fall together or will there be a difference of time, and why? So I'm doing the experiment. So can you guess before you give answer which one is going to fall?
Just a guess, no points for that, Shantanu.
Yeah.
Come on.
Loaded one.
Okay, let's do the experiment. Now you have to hold them down, little down. You put your hand at this level, maybe both hands. Okay? Now just a little down, please. I drop them. Which fell? The lighter one, without load. Okay? Can you go down, further down? Yeah. So you got the lighter one first. Now the question is, what is the physics behind this?
It has enough thrust. The air acting force.
I'll do it once again.
Yeah, it has a greater thrust. You have any
I
answer?
think you can take your seat.
Which one fell first?
Thank you. Must hurry up, less than 10 seconds to go.
Still, it
Yes.
has a greater
Is it because the moment of inertia of the heavier rod increases? So as such, when it rotates, when it falls in an angular way, the arc traced out, the angle traced out is less because the angular velocity will be less. If
You are
momentum
right.
is same
You
torque.
are absolutely right. You get 20 points for this.
Well done, Vaibhav.
Your guess was wrong in the beginning, but this is what exactly happens. As a load which is on this one increases the moment of inertia, so as a result the speed of rotation, because the axis was down on the floor, along which both the rods were rotating. So the speed, angular speed of this one was less than that of this one. So you get 20 points for that.
Mr. Rotella, I have a question for you. Suppose both of us were to fall off a cliff, does that mean that you will reach first?
Well, if I have a load on my head, I might be later than you.
Okay, well that answer there
But
certainly removes the load from your minds, boys. 20 points you pick up, scores are now 20 points each. That's JC Bose and CV Raman team. And we move on to the next question.
I have a thing to add on this.
Oh yes, you do, please.
Well, when you open a door, the handle is always put at the end of the latch. Why not at the hinges? When the handle is very close to the opening end of the door, the moment that you get is much higher because of the force arm, right? It becomes easier. So you can even push it with a finger, whereas at the hinge point, if you push it, it needs a lot of force. Okay?
Well, their answer certainly opened the right doors for them here. We'll be back with the next question shortly. Welcome back. You're watching Quest, the inter-school science quiz brought to you by Doordarshan Kendra Kolkata and the National Council of Science Museums. Scores at this stage, 20 points apiece. The next question is the fourth. That's the last of the direct questions, and that's for the CV Raman team, the boys from La Martiniere.
Well, I have a setup here. I have a rod which is free to rotate, and I have two loads which are also free to slide along this. Now the question for you is, when I hold these loads here and rotate it fast, why do the loads go away and why it becomes slow?
Well, the loads go away because of the centrifugal force acting on the loads, which is more than the frictional force. And then we know it very well that when a ballet dancer, she dances, when she needs to rotate faster, she keeps her hands by her sides, and when she needs to slow down, she outfolds her arms. It's the same case in this one, because the rotational motion, the rotational torque acting on it is more when the two loads are very near to the body, while when they go away from it, the moment of inertia increases, and therefore the
It is the tendency of two particles undergoing this type of motion to maximize the distance between them, and that's why we find them at the two ends.
Tell me why the rotational speed reduces when this goes to the end.
Yeah, when the rotational speed is maximum when is more when the total mass is centered around the body, then it is away from the body, and this is due to moment of inertia. No, moment of inertia.
It tends to stabilize around those two.
I'm hearing your whispering, you're right, almost right.
Yeah, it's the moment of, is it the moment of inertia?
Increases. You're
Inertia
right.
increases.
We give you 20 points for this. Well, you are absolutely right. When the loads are here, the R is less, the radius.
Yeah.
And when the loads are away, R is more, mass is same. So when R increases, moment of inertia increases,
Yeah.
mr square ratio. And when the R is less, moment of inertia is less, the speed is more. And you are right, this is has a direct application in ballet dancers or even in what you call circus sometime. And the dancer or the ballet dancer tries to stretch the hands to reduce the speed and bring together to increase the speed.
You mean when making a pirouette?
Yes, you are right.
Gaurav, you're not going to show us some ballet dance, are you?
No, thanks.
No such leanings?
Not yet.
Anyway, you pick up 20 points for your team. Your team now moves on to 40 points. That's C.V. Raman on 40 and J.C. Bose still on 20. The next question will be on the buzzer. Onwards to the next question, which is the fifth question today. This one's on the buzzer, as are the next two. Plus 20 if you get it right, minus 10 if you get it wrong. Remember, teams, at whichever point you hit the buzzer, you must have an answer ready, because these questions will not pass to the other team. They'll go straight to the audience. Mr. Rotella.
Well, the question for J.C. Bose team is, I have a potato purchased from Calcutta market, and I have a straw. When I hold the straw this way and try to push it, nothing happens. But when I put my finger here and I do this, it goes through. Once again, when I do this, nothing happens. When I put my finger, this goes through.
C.V. Raman
Yes.
team.
Okay. When you just push it without your finger at the top of the straw,
Yeah.
there is air inside that straw. That air, when it comes into contact with the potato, it can easily come out from the other end of the straw. However, when you have your thumb on the top of the free end, that air is getting compressed. There's no way it can get out. So it also exerts a force on the potato, as a result of which the straw goes right through the potato.
The force due to atmospheric pressure.
Well, you are right, but the air doesn't exert any pressure. Air tries to keep it stiff enough.
Yeah.
Because that's the only one. There's another point to this which I would, of course I'm going to give you 20 points for this.
Let's have a big hand for them then.
Can you add to this? Tell me what else happens while hitting this way.
The force is less, and in this case the force is also more.
No, it's not more. There's a reaction in the finger. Okay?
Yes.
There's a reaction to that force, so it exerts the reaction further force to that. There's another point which I would like to add is the construction of this straw. This way it is stronger, and this direction it is very weak. I can compress it this way and very strong this way. All right?
Okay.
So that's another point which you can add to this. So you get 20 points.
Thank you, sir.
Thank you.
Well done, Harsh. You pick up 20 points. Your team now moves on to 60 points. Boys from J.C. Bose team, you're still on 20. Well, I hope that's not the last straw for you. Buck up. Let's see you do better in the next two questions, and we'll be back very shortly with the same. $60 points then to C.V. Raman team and 20 to J.C. Bose. Come on, boys, do something about it. Are you ready for the next question? Let's have a smile on your face and your fingers on the buzzer. Mr. Rotella.
Well, I have a glass tube and a brush. What I do is I push the brush a little bit on this and hammer the tube from the top. Now the brush goes in and it comes right up to the top. Tell me what makes it to slide up. Yes.
Yes, Shantanu.
Because when we apply the palm,
Yeah.
when we take out the palm, it acts as a suction, which takes out the air inside the test tube, which creates a vacuum, and hence the brush is pushed in. Every time it's done this, it goes in little by little.
From bottom side is open.
The bottom side is open, but the brush is blocking it. So
It follows from Bernoulli's principle. When you are beating the open end of the tube, what happens, the greater velocity is imparted to the air surrounding it. So the pressure falls, so the brush rises up the tube.
No, I don't think I would give you an answer.
Now, minus 10 then.
Yes, they get 10 minus 10 points.
I'm sorry, Shantanu and Vaibhav. Audience, anybody? No one in the audience? CV Raman team, no points if you get an answer, but would you like to try?
Anybody try?
Genetic engineer, are you trying?
Try it yourself. You can try this.
Would you like to have a go?
Keep hitting from the top.
Okay, now what's happening is
Well, the answer was very simple. Don't go into very complicated answer sometime. It is nothing very simple inertia because the brush is free. The brush is free here. When you are hitting the tube, the inertia of the brush tries to keep its original position because you are pushing so it tries, and the strands get a little compressed and it goes back to its original position every time and it slides. That was as simple answer as I would have expected from you.
Well, bad luck, boys. You lose 10 points there. You move down to 10 points. JC Bose then on 10 points, CV Raman on a handsome lead of 60 points. Let's see what happens in the next question. Now with the scores reading 60-10, yes, that's right, 60 points to the CV Raman team and 10 to the JC Bose team. The very final question of today's episode of Quest. Dr. Rotela, what do you have for us?
Well, I have a simple button made of a metal or metals could be. It is concave on the top with a small dent, but the other side of it there is a small notch. Okay, I'm going to rub the notch side and compress it, make it concave up. Now it is convex from the top side, and put it on this table and watch it what happens.
Already hit the buzzer before anything happened. Yes, why don't you tell us? What is going to happen and why?
It returns to its original shape because when you rubbed it, you imparted heat to it.
Yeah.
As a result of it, a stress developed due to which you could push it on the opposite side. You could create the indentation on the opposite side. Now once the heat is lost, it returns to its original shape because the stress is now nullified.
Stress of what type?
It's a thermal stress.
Well, you are close to the answer, but you are still not on the dot, so I won't be able to give you points for that.
But I'm sorry, we'll have to take away 10 points in that case. Anyone in the audience want to hazard a guess? Yes, why don't you come up here? Come here. What's your name?
Hello, my name is Bhaskar De and I am from 𝐶𝐞𝐦𝐨𝐬𝐭 Mission School.
Come this side. Yes, Bhaskar.
The coin is made up of a bimetallic strip. When heat is imparted to it, one side of it expands more than the other, and so it's easy to bend. And when it's kept on the metal, heat flows away, and so it so the bimetallic strips try to regain its original shape, and it becomes curved on the other side.
You are absolutely right.
Let's have a big hand for him then. Yes, Mr. Rotela.
So he was right. This is made of two metals, which is, one of them is having very high expansion coefficient, other is very less. So they are fused together at about 75 degrees Fahrenheit, that is about 25 degrees Celsius. So when I rub it and raise the temperature, the one side expands more than the other side, and when I compress it and put it down, because that side comes fast, as a result the compression makes it concave again, and it jumps up because of the notch on the other side.
Well done, Bhaskar. We have a small memento for you.
Thank you.
Well done. You can go back to your seat. And now the final score tally. The CV Raman team, that's the boys from La Martiniere, have done very well. They've got 60 points. Let's have a big round of applause for them.
Thank you, sir.
Thank you.
Thank you, sir.
A small
you, sir.
memento from Quest. We hope you enjoyed being on our show. JC Bose team, bad luck. You're back to square one. That's no score at all. Anyway, you can smile. It's a small memento for you from Quest. We hope you've enjoyed watching our show. Please write back to us with your comments. Our address, Quest, care of Doordarshan Kendra, Kolkata, 18/3, Uday Shankar Sarani, Golf Green, Kolkata, 95. We'll be back again next week with 7 new experiments and 2 new teams. Till then, it's goodbye from all of us here at Doordarshan Kendra, Kolkata.